Hello and welcome back to this course of videos on Node.js. Now if you remember, look at the code on the screen. That was from the previous video where we looked at synchronously reading and writing files. Now synchronously is actually a blocking way of running code, and we want to look in this video at the asynchronous way of performing exactly the same thing, which is a non-blocking way. Now it's very important in Node that we run our code non-blocking. If you remember to a previous video, Node has a single JavaScript thread. But it can still work very effectively because it picks up events from the event queue and immediately passes off to the C++ thread pool where that does its work. And then immediately the single JavaScript thread on the event loop is then freed to take the next request. So this is the way it works asynchronously. When you're working synchronously, which is the code you can see up on the screen there, so when the event loop takes that takes this file and starts reading it, it's going to process the fs.readfile sync. So it is going to pass off to the thread pool and say, okay, can you please read this file to the C++ thread. However, our thread is going to be sitting idle. And if you remember when we were talking about CPU cycles, reading and writing to disk can be approximately 4 million CPU cycles. So for that period, while that code were running the fs.readfile sync for the 4 million CPU cycles that it's taken to read from disk, our single JavaScript thread is sitting idle. Same thing happens when we move to the next line of code, fs.writefile sync. Again, it's going to pass that command off to the thread pool, which is to be handled by the C++ modules. But it's going to sit there idly. That's synchronous programming. What we want is asynchronous. We want it to pass off these tasks to the C++ modules, but then we want it to be immediately free to pick up the next event on the event queue. Now, with asynchronous programming, the way that works is once the C++ module has completed with the read or write file, then they will pass back a callback function to the event queue, and on the next tick of the event loop, they will pick up that callback function and execute it. So that way your code is free and you're not starving your thread. We talked about thread starvation before. This could be an example of thread starvation. If the file was big enough and it had to read, it was sitting idle while a massive file was being read, then that would be starving the thread. Now, just the last point I will make, the console.log contents, obviously it's not a crucial piece of code, but if it was, it would be a problem because our JavaScript code as it's running through, that console.log will not be run until the read file sync has been processed and returned, and then the write file sync has been processed and returned, and then and only then will the console.log piece of code be read and actioned by Node. But with our asynchronous program, which we'll see in a sec, those two requests to read file sync and write file sync will be passed off to the thread pool, and the single thread will be free to continue execute it, and it will execute that console.log line straight away. So stay with me and we will look at asynchronous programming. Okay, so let's turn our synchronous blocking code into asynchronous non-blocking so we can keep our single JavaScript thread free to handle the subsequent requests that come through the event queue. So the first thing I'm going to do is just delete the console.log, we don't need that, or the variable declaration, make a bit of room, and I'm going to change my read file sync to read file. Now this is the asynchronous version, so imagine it says read file asynchronously. This is just shorthand. Now, for the read file method, as we mentioned before, this now needs a callback function. Now this callback function will be executed once the C++ thread pool has finished its job of reading the file. Then this callback function that we're about to add will be added to the event queue, and on the next tick of the event loop, this callback function will be actioned. So we'll pass it in as a third parameter here. I'm going to do an ES6 arrow function. Now this function is going to take two parameters. One of them is the error object and one of them is a data object. The error object we can use to handle the errors in the event of error, obviously, which is a good idea because otherwise your Node program can stall. I'm not going to do it right now, but in production I would at least do a console.log and just log out what exactly the error is. The data object is going to contain the data that is read from the file. So this data argument that is being passed in here will now be available to us in our function, so we can actually use that data. The next thing I'm going to do is look at the writefile sync and turn that into the asynchronous version. So I'll just change from writefile sync to writefile. Again, this is going to need the third parameter of the callback function. In this case, we only have the error object. There is no data object. It's not applicable as we're writing to the file. And all I'm going to do in the function here is just console.log file written successfully. Now, what I'm going to do is I'm going to take this fs.writefile and I'm going to put it into the callback function of the fs.readfile. So once the file is read, the callback that's going to be called, the callback function, will actually write the file. So I am just going to cut and paste, just to get the formatting. So now you can see we have, this is an asynchronous read file, and the data is going to be read and made available in the callback function that will be ran once the read file is complete. Now you can see I'm going to need to change its contents to data. So this data object that is passed in on this callback, I'm actually using it in my fs.writefile, and then the function, the callback function, once this write file is complete, is this console.log here. I'm going to put a semicolon on the end. You don't need it, but I like to be pedantic, as I said before. Now, the key thing to note here is I don't have any code down here, but if I did have code down here, important code, this read file and write file isn't going to tie up and starve the single JavaScript thread, so it can't continue with this further code down the page. Previously it was, if you remember, but in this case it will run the fs.read file and then will just continue, because it is asynchronous, it will just register the callback and then proceed immediately onto the rest of the code, which is the non-blocking aspect of Node and the way to use it. So just to prove that this code is going to work, I'm going back to my Windows Explorer. This is the file that we're writing here. Here's my text files folder. I'm just going to delete the writeme.txt. I'm going to go back to my git bash and I'm going to run our code here. And you can see it comes back, there's a console.log, file written successfully. So obviously the read file executed, then the write file executed, both of those callback functions, and then as you can see the writeme.txt was created. So I hope that gives you a good overview of the difference between synchronous and asynchronous programming, as well as how to use the read and write file. I look forward to seeing you in the next lesson.